Okay. Good morning. In the last class, we have discussed discussed about different types of diseases like vector-borne diseases, malaria, plague, dengue, etc. Vector-borne disease means which spreads through a vector. For example, mosquito, blood-sucking insect. Then we have discussed about the different types of diseases based on their area of impact, like endemic, epidemic, and pandemic diseases. Later, we have started about discussion about physics, basic concepts of physics. There, we have discussed about SI units, 7 fundamental units of measurement. Then, important measuring instruments. Then, dimensional formula we have discussed. Later, we have discussed about. We have started discussing about light. Light travels in straight line. If light falls on a plane surface, the light ray will be reflected. Law of reflection says angle of incidence is always equal to angle of reflection. Angle of incidence will be always equal to angle of reflection. Law of reflection. Then a refraction. Denser medium, for example water, a rarer medium, for example air. If light travels from one medium to another, light will bend. The bending of light is called as a refraction. Bending of light, a refraction. And we have discussed different daily life applications, effects of refraction. For example, depth of a pool appears to be less due to refraction. If you keep a pencil inside a water filled glass, it appears to be little bent and short. That is due to refraction. If you put coin inside a water glass, coin appears to be raised a little bit. That is due to refraction. Twinkling of star is due to refraction. 2 minutes early sunrise, 2 minutes late sunset, that is also due to a refraction. Then we have discussed about total internal reflection. For total internal reflection to happen, TIR, total internal reflection to happen, there is a condition. Light should travel from denser medium to rarer medium, from higher density medium to lower density medium. First condition, light source should be in the denser medium. Then angle of incidence should be greater than critical angle. Angle of incidence should be greater than critical angle. Then instead of going to the other medium, light rays reflect in the same medium. This is called as total internal reflection. Applications of total internal reflection are mirage. Mirage means during summer days, during hot summer days, in the afternoon usually, on the tar road, it appears to be there is water on the road. But when you move towards that water-like appearance, it fades away, and in some more distance, it might seems like water is there on the road. That effect, that illusion is mirage. Mirage. Then optical fiber cable uses a total internal reflection. Optical fiber cable. Then we have discussed about a diffraction. Diffraction and a dispersion. Diffraction means bending of light on the edges. Sunlight when it travels through the edge, it bends. The bending of sunlight, the bending of light. Due to the bending of light, the glow appears around the cloud. For example, if I put a flash here around my face, there is some kind of glow seen, right? That effect, the phenomena is called as diffraction. Diffraction. Then a dispersion. When white light passes through the prism, white color light passes through the prism, it is split into 7 colors. White light is made up of 7 colors: violet, indigo, blue, green, yellow, orange, red. Most deviated color violet, least deviated color red, red least deviated color. In danger signals, traffic signals, then vehicle's tail light, generally red color light is used, right? Why? The reason is red light is least deviated from its path. It is least deviated compared to other colors. Then it is having longer wavelength. Red light have longer wavelength. That is the reason red light is used. It can be seen from a longer distance also. That is the reason red color light is used. A rainbow. We have discussed the concepts till here from rainbow. How a rainbow is formed. In SSC examination, RRB examination, they have given question many a times regarding this rainbow, how it is formed. A rainbow is not formed due to a single effect, single phenomena of light. It is due to combination of different phenomena of light. For example, a rainbow is formed due to a reflection of light, a refraction of light, bending of light, dispersion of light. Dispersion means spreading of white color light into 7 different colors. White light into 7 different colors, splitting of light. Then total internal reflection. Total internal reflection. All these 4 phenomena combine to form a rainbow. A rainbow is formed by these 4 phenomena. In an examination, what they have asked, they have given 5 to 6 phenomena of light, like diffraction, interference, polarization, etc., etc. And they have asked, among these 6, 7, 8 phenomena of light, which 4 are required for rainbow to occur? They have asked, you need to choose among them. A reflection, a refraction, a dispersion, total internal reflection for the rainbow to be formed. Generally, when a rainbow is formed, a rainbow is formed due to 4 phenomena of light: reflection, a refraction, dispersion, total internal reflection. Four phenomena: a reflection, a refraction, dispersion, then total internal reflection. Four phenomena. When generally rainbow is formed, after rain, when sun shines brighter, right? When sunlight is also there, few drops of rain is also coming, right? Bisilu mada time nalli usually rainbow is formed, right? In examination they have asked, if observer is here, the sun should be behind the observer, right? Then rain droplets, water droplets will be in front of him. Then only he can see the rainbow. If you are sitting in a film theater, projector will be behind you, then screen will be in front of you, right? Same. Sun will be behind the person. Rainbow is formed in front of the person. Rainbow. Observe the first droplet. White color sunlight is entering the water droplet. Some portion of light is reflected. Some portion of light. Then refraction, bending of light rays happening in both the sides. Then dispersion. Dispersion means splitting of white color light into seven colors, white light into seven colors. Then internal reflection. Instead of going from water droplet to air, light is reflecting in the water droplet itself. So combining all these four phenomena, rainbow is formed. Rainbow is formed. At the top of the rainbow, which color the person can see? Red. See, if you see a single droplet, a single drop of water, violet is at the top, violet is at the top. But when a person observe from far, red color light is seen at the top. When a man sees the rainbow, a red color will be at the top of the rainbow. Right? Blue color of sky is due to, blue color of ocean is due to scattering of light, spreading of light, right? More scattered color is blue, that's why it appears blue. We have discussed yesterday. This lens is called a convex lens. This is concave lens. Concave lens. When light passes through this lens, what happens? It will converge and meet at a single point. Converge. When light passes through this lens, it will diverge. It will diverge. Here, light rays meeting at a point. This is called as principal focus. Principal focus. Center point where the light rays come and meet. Principal focus. The center of the lens is called as pole of the lens. The distance between the center of the lens and the principal focus is called as focal length. Focal length. Here, the focal length cannot be seen because it is diverging. If we extend the light ray backward, imaginary extension, if we extend, here the principal focus is seen. This is the focal length. This is the focal length. In convex lens, if someone has any sort of eye defect, then if he goes to a ophthalmologist to check his vision, if there is any problem, doctor will suggest suitable focal length, spectacle, lens, right? He will suggest. He might suggest a lens with the power of the lens. If someone is wearing a spectacle, what generally do we ask? Is it a power glass or not, right? We do ask, does it have power or not? Power of the lens, power of the lens, power of the lens. It is measured in diopter. Power of the lens unit is diopter. Diopter is equals to 1 by focal length. 1 by focal length. Diopter is equals to 1 by focal length. If the power of the lens is minus 0.25D, in an examination SSC they have asked whether it is concave or convex. The power of the lens means, see, where in these two conditions focal length is positive. Yes, in the first case, right? In the convex lens, it is in front of the lens. That's why focal length is positive. When the focal length is positive, power of the lens is also positive. Power of the lens is positive. Here the focal length is negative behind the lens. That's why power of concave lens is negative. Power of concave lens is negative. Then here minus 0.25D, this lens will be concave, negative powered concave lens. If a person suffering from myopia, nearsightedness, myopia, then this person is suffering from myopia. Myopia means he can see nearby objects clearly, but he cannot see farther objects clearly. Myopia. Then if the power is positive, convex lens, this is negative, positive convex lens. Hypermetropia, farsightedness, he can see farthest objects clearly, not the nearby objects. That can be corrected with the help of convex lens. Corrected with the help of convex lens. Okay. Power of the lens. Power of the lens is measured in diopter. Power of the lens measured in diopter. Okay. Then let's move on to the next chapter. Heat. Heat is the form of energy. It is a form of energy. Assign it of work. Assign it of heat. Assign it of energy. Assign it of kinetic energy. Assign it of potential energy. All is joule. Assign it joule. Assign it of heat is also joule. Assign it of heat. Okay. Heat means generally if we eat more spicy food, chicken, for few days continuously, then we will say little bit heat. I think I have. That is completely different. This heat is different. If you touch the desk, it feels little cold, right? If you touch the metal part of the chair, it feels more colder, right? Actually, the temperature, this room temperature, each and every object will be nearly at the same temperature. Even the wall, desk, window, metal railings, etc. But few objects feel less colder, few objects feel more colder. The metal objects usually feel more colder, right? We'll see. Heat means total kinetic energy, total kinetic energy present in a substance or in a material, total kinetic energy. That means if you started to heat this metal piece, if you starts to heat this metal piece, what will happen? The molecule present here will expand. Upon heating, molecules will expand. Upon cooling, molecules will compress. Expansion, compression will happen, right? The particle will expand. The heat is transferred to the adjacent particle. Conduction, then to the adjacent, then to the adjacent particles. If you place a metal piece into the flame, after some time, the other end will also feel hot, right? Because heat is transferring from hotter end to colder end. All these particles are having kinetic energy right now. Kinetic energy of particle 1 plus kinetic energy of particle 2, kinetic energy of particle 3, 4, 5. The total sum is called as heat. Total kinetic energy of all the particles, that is heat. For example, if I give you this bottle of water and I ask how much amount of heat is present here, generally we cannot feel, right, how much amount of energy is present or heat is present in this water bottle. Generally we don't measure heat in joules, but we do measure temperature. If I touch this water bottle, it feels little colder. If I touch a hotter object, for example, the fan, it feels much hotter, right? The degree of hotness and coldness is called as temperature. Degree of hotness, coldness called temperature. Heat means total kinetic energy. Let us see the difference between heat and temperature. Heat and temperature. Heat means total kinetic energy of all the particles. Temperature means degree of hotness or coldness. If you touch an object, if you touch any object, if you feel hot or cold, that measurement is called as temperature. SI unit of heat is SI unit of heat, joule. SI unit of temperature. Temperature is measured in generally we Indians measure temperature in see unit of temperature. For example, boiling point of water, melting point of ice cube, freezing point, etc. We know, right? Boiling point of water is 100 degree Celsius. 100 degrees Celsius. Degree Celsius we do use Indians, but that is not the SI unit of temperature. SI unit of temperature is Kelvin. SI unit of temperature is Kelvin. Earlier we had clinical thermometers, the physical thermometers we do put into our mouth and check the body temperature, right? Right now we have infrared digital thermometers, no need of physical contact. Just by the help of radiations, we can detect any body's temperature. Heat is dependent on mass of the object, mass dependent. Why mass dependent? See, this object, this is having 2 molecules, this is having 6 molecules. If we heat these 2 objects, kinetic energy present in each molecule is 1 joule. Then where more heat is present, total kinetic energy here is 2 joule. Total kinetic energy here is 6 joule. More heat is present in the larger, bigger, high massed object, right? mass matters with respect to heat. But here there is a small object, there is a big object, small object at 20 degrees Celsius, big object at 20 degrees Celsius. For example, a bucket of water, a mug of water. To take bath, you have filled the bucket of water. Hot water is present in the bucket. To check if the temperature is good for you to take bath, you have taken the water in this mug. If you dip your finger inside this mug and this bucket of water, in both these cases, the temperature will be same, right? Temperature does not depend on mass. Temperature is dependent on degree of hotness, coldness, that's it. Not depend on the mass, but heat is dependent on the mass, depend on the mass. See, for example, your gas stove, you are preparing a big bowl of tea, a small bowl of coffee. Let's assume both boiling point is 100 degrees Celsius. Let's assume 100 degrees Celsius. Initial temperature 20 degree, initial temperature 20 degree. If we give same amount of heat, flame, which will be ready fast? The smaller one, coffee, because the mass is less, right? 4 molecules. Here, 12 molecules. If I heat a coffee to 100 degrees Celsius and tea to 100 degrees Celsius, temperature right now in both coffee and tea is same, right? 100 degrees Celsius. If I dip my finger in both coffee and tea, same amount of burning happens because temperature is same. Temperature is not dependent on mass quantity, right? But heat is dependent on mass. Where heat is more at same temperature, coffee or tea, more amount of heat means total kinetic energy of all the molecules. Where mass is more in the tea, right? Here it is more. For example, let's say you have used a 100 ml of LPG, 100 ml of LPG to heat this coffee. Obviously, you must have used more amount of LPG to heat this tea, right? More quantity. Then more fuel, more heat generated, more amount of heat present in tea. Mass is more means heat will be more. Mass less means heat will be less at same temperatures, right? But temperature is not dependent on temperature, not dependent on mass. Mass. SI unit of heat, joule, joule. SI unit of temperature, Kelvin. Temperature's SI unit is Kelvin, Kelvin. In Bangalore, they are doing white topping in many areas, many roads. White topping, cement, concrete roads, right? They first construct the road, then they will cut regular intervals. They will make a cut. They will fill some tar, etc. Right? Why are they cutting the road in regular intervals? Have you seen? Right? They do, right? Even in the railway track, in the parallel two tracks railway track, there they give some gap, some amount of gap they provide, right? In the flyover bridges also they will provide a small gap. Reason? The reason is when an object is heated, it will expand. When object is cooled, it will compress. Expansion and compression will happen in this concrete road, in this railway track, in the bridge, etc. Due to the expansion and compression, if there is no gap present, the structure might get crack, breaks. That's why to avoid any distortion in shape, to avoid any cracks, the space is provided. The space is provided. to allow thermal expansion, to allow space for thermal expansion, the gap is provided. From the seasonal temperature variation, summer to winter, the material will expand or contract. Due to that, it should not get any cracks, deformations, distortions. That's why the gap is provided. Thermal expansion, to allow thermal expansion to happen. There is a glass jar. If you pour hot liquid into the glass jar, suddenly if you pour hot liquid into the glass jar, it might break. Generally it will break. Why? Glass is not a good conductor of heat. The glass which we use in our kitchen, it is resistant to some temperature, the normal boiling point of water, normal boiling point of milk, etc. The temperature it can sustain. If the temperature is more than that, it will break. What will happen? The inner layer of glass tries to expand. Inner layer of glass, it tries to expand. At the same rate, outer layer will not expand. In the rate of expansion of the inner layer, outer layer will not expand. Due to uneven expansion, the glass breaks due to uneven expansion. Which are the good conductors of heat? For example, good conductors of heat which carry heat better. Good conductor means which transfer heat better. Not an insulator which avoid heat, which transfer heat better. Metals, generally the utensils you use at your home are made up of metals, right? The tawa to make chapati, it transfer heat better, right? Metals are good conductors of heat. Plastic, wood, air, water, etc. are poor conductors of heat. Water is a poor conductor of heat, but water will also gets heated, right? It heats up slowly, cools down slowly. It takes more amount of time to get heated and more amount of time to get cooled. That's why it is a poor conductor of heat, bad conductor of heat. If an object heats at a faster rate, cools down at a faster rate, that is a good conductor. Generally, metals are good conductors of heat. Metals are good conductors of heat. Bimetallic strip works on the principle of thermal expansion. Bimetallic strip works on the principle of thermal expansion. At your home, you might have observed your electric geyser, water geyser, electric geyser, and your refrigerator, your water heating kettle, and your iron box, right? When you switch on these instruments, it will create a tick sound. Iron box, let's say, it will make a sound, right? Then the light starts to glow, red light. Then upon heating, when the temperature increases, then a tick sound comes. Then the light is turned off. You have plugged in, it switched on. Then also it switches off automatically, right? Upon heating to some temperature, your electric geyser will also automatically switches off. The automatic switching on, switching off, that is due to this bimetallic strip. Your refrigerator, sometimes the compressor stops. After some time, it suddenly starts You might have heard the sound, right? That is because this bimetallic strip. For example, if you place a temperature sensor, a circuit that takes more amount of time, effort, money, right? Difficult circuit. This is a simple circuit, bimetallic strip. See, by means two metal strips are placed like this, two metallic strips. If you apply heat, means the temperature is increased. Upon heating a object, it will expand. Upon cooling, it will compress. Expansion, compression. By heating, expansion. By cooling, compression. Right? When temperature is increased, when the temperature of the object is increased, it will open. Circuit is open. If you remove two wires which are connected together, current will not pass. If you connect it back, current will pass. Same mechanism. Bimetallic strip, it will close to allow the flow of current. It will open to avoid the flow of current. Bimetallic strip. The tick sound which we get is due to this bimetallic strip present in all these equipments: refrigerator, air conditioner, iron box, electric geyser, incubator, etc. All these equipments. This works on the principle of thermal expansion. Works on the principle of thermal expansion. Then very important concept, anomalous expansion of water. Anomalous expansion of water. Anomalous expansion of water. Anomalous expansion of water. See, when you heat any object, the molecules will move away. Right? Expansion happens. When you cool, it will come closer. Compression. During some time, how will you sleep? Freely, so that more amount of at least air comes. During the time of winter, you feel compact, closed, so that you feel little warmer, right? Likewise, upon heating, the molecules will move away. Expansion. Upon cooling, the molecules will come closer. Compression. Heating, expansion, cooling, compression. Normal conditions. See, if the molecules come closer, the density of the object will increase. Density means, let's assume this object is having a volume of 1 meter cube. 1 meter cube. Okay. If I place cotton inside it, cotton, the space between the cotton fibers are more, right? The density is less. I can still press and make space. If I put thermocol, compared to cotton, it might be more, but still it is less. If I put sand, more dense. If I put melted metal, once it cools down, the density will be high, right? The density means in this space, how much molecules are present, how much molecule mass is present, that is density. Have you seen the movie Titanic? Iceberg floats on the surface of water. Iceberg, big, large, huge iceberg is floating on the surface of the water. Generally, if you put ice cubes into the water bottle, glass, what will happen? It will float or sink. It will float, right? Iceberg is floating, even ice cubes will float in water. Generally, in other cases, if a solid object is placed inside the liquid, it will sink, right? If you place a stone, an iron piece, wooden block, it will generally sink in water. But why the solid ice cube is floating on the surface of water? Solid ice cube is floating. Other solid objects are sinking. Reason is density. Density. See, generally, Upon heating, the objects will expand. Upon cooling, the objects will compress. Let's say, for example, these are the water molecules. These are the water molecules at a temperature of 25 degrees Celsius, room temperature. You started to cool these water molecules. Upon cooling, it will compress or expand. If you heat, it will expand. If you cool, it will compress, right? Upon cooling, it will compression. Compression till 4 degrees Celsius. Till 4 degrees Celsius, it will compress. Till 4 degrees Celsius. At 4 degrees Celsius, molecules are compressed to its fullest maximum potential. It got compressed from 4 degrees Celsius. Now also you are cooling the water. 4 degrees Celsius, water is in liquid state. Water is in liquid state. 25 degree, obviously liquid state. Okay. Then what is the freezing point of water? Temperature, freezing point. 0 degrees Celsius. Freezing point of water is 0 degrees Celsius. From 4 degrees Celsius to 0 degrees Celsius, you are cooling water. By cooling, compression is happening, right? Compression. If in case the water molecule still compress, the density will increase. The weight of ice cube will be more. Then ice cube will sink in the water. If that happens, that is not happening right now. If that happens, what will happen? Water in the cold countries. Have you seen any frozen lake? Frozen lake, in movies at least. Frozen lake, right? The frozen lake will be frozen from the top. In the bottom, water will be in liquid state, right? They will make a hole and sometimes they will fish, right? If in case the density of this water is more, if it still gets compressed, what will happen? The water will freeze from the bottom. If the water freezes from the bottom, all the aquatic life will be dead by freezing. That's why God gave a special feature only to water, a special feature called as anomalous expansion. Anomalous expansion of water. Anomalous expansion. Anomalous expansion means normally during this case, upon cooling, it should not expand, but it is expanding. Asambhaddhavagi. Anomalously, it is expanding, right? Anomalous expansion, the molecules will expand a little bit, not this much. Little bit expansion. Little expansion is happening here. Molecules will expand. Volume increased. Volume means the amount of the space it occupies, it is increased. Volume increased. Then density decreased. If you fill water to this bottle to the fullest and close the cap and place it inside a freezer, when the water inside it converts to solid ice, can you place this water bottle on the table like this? Actually, it is not possible. What will happen? The bottom of this bottle will bulge. Try once. If you have Kinley Bisleri water bottle at your home, fill the water to the fullest and convert it into ice. Once it is converted to ice, obviously the bottle will bulge. You might have seen the bottle will bulge. The bulging is called as increase in volume. The size, the quantity, it will increase. Density is decreased. That is why ice floats on the surface of water. Ice floats on the surface of water due to anomalous expansion. Anomalous expansion. Anomalous expansion happens between what temperature? 4 degrees Celsius to 0 degrees Celsius. Anomalous expansion is happening. Highest density of water is seen at highest density of water. See, molecules are far away. Molecules are little bit away. Molecules are compactly packed. Where density is more? Where the molecules are compactly packed at 4 degrees Celsius. At 4 degrees Celsius, highest density of water is in highest density of water at 4 degrees Celsius, highest density of water. This is a very important concept which we should know. See, in many examinations they have asked this question. In cold countries, water pipe burst due to. In cold countries, water pipe burst due to, because the water inside the pipe, the liquid water inside the pipe is converted into ice and it expands. Water converted to ice and it expands. That's why the pipe will burst. That is due to anomalous expansion. Anomalous expansion. Ice cube floats on the surface of water. Ice floats in water because the density of ice is less than the density of water. Density is less, low density. Why low density? Due to anomalous expansion. Due to anomalous expansion, the density is low. That's why it is floating on the surface of water. It is floating in the water due to anomalous expansion. Anomalous expansion. Conduction. There are three modes of heat transfer. Conduction, convection, and radiation. Conduction, convection, and radiation. For sound to travel, is medium required? For sound, medium required or not? Medium means air, water, solid medium, etc. Yes, medium is 100% required. Sound will not travel in vacuum. Sound does not travel in vacuum. Will heat travel in vacuum? Will light travel in vacuum? Yes or no? Will it travel? From sun to the earth, we are getting heat and light, right? From the sun to the earth, you are getting heat and light in the form of radiation. There is no atmosphere present between sun and earth. There is vacuum. Hence, heat and light will travel through vacuum. Heat and light will travel through vacuum. There is no medium required. Conduction means conduction. Generally in the solid objects, solid objects, if you are heating the object here, the molecule present here will expand and it will transfer heat to the adjacent molecule. Likewise, the heat will be transferred from the hotter end to the colder end. Heat is transferred. This is conduction. Examples for conduction: if you walk barefoot on the tar road in the afternoon, what will happen? Burning sensation you feel. That is conduction. Conduction by two solid objects coming in contact from the hotter end to the colder end. The heat is moving. Conduction. For example, say In an examination, they have asked, this is the plastic cap of a pen, sorry, metal cap of a pen, metal cap, then plastic body, metal cap. Both are at 15 degrees Celsius. Both are at 15 degrees Celsius. 15 degrees Celsius. See, the desk at 15 degrees Celsius. The metal part of your chair, at 15 degrees Celsius, which feels much colder, metal part, right? Likewise, here also, compared to the plastic part of the pen and the metal cap of the pen, this feels much colder. Feels much colder. Reason? Reason is that, see, when you touch the cap, when you touch the plastic body, right? What is our body temperature? Standard human body temperature. Human body temperature is 37 degrees Celsius. 37 degrees Celsius human body temperature. Standard average human body temperature. Our body temperature is 37 degrees Celsius. This plastic 15 degree, this metal cap 15 degree, right? Both are at 15 degree Celsius. Plastic is a good conductor of heat or bad conductor of heat? Bad conductor. Wood, plastic, etc. bad conductors of heat. Metal, it is a good conductor of heat. We have seen conduction. Conduction means flow of heat from hotter end to colder end. Now, hotter end is human body, colder end is the metal. That's why when it is a good conductor, it absorbs more heat from us. When you are touching the wooden table, it is not absorbing much heat. When you are touching the metal part, it is absorbing more heat from us. That's why we feel much colder. It is absorbing heat from us. That is the reason we feel much colder. Conduction generally seen in solid objects, solid from hotter into colder end. Conduction. Convection. Convection. Generally seen in gases and liquid. Gases and liquid. Have you observed water being heated in a bowl, pan, container? Heating of water. If you start to heat water, what you can observe? Small air bubbles will start to form at the bottom, right? Small air bubbles. Then the heated water travels upward. The heated water travels upward. Hot water will be stored at the top. Then cold water from the top will move downward. Cold water from the top will move downward. This thing will happen. Literally, movement of molecules from hot to cold, cold to hotter region. Movement of molecules is seen. This is convection. I am feeling little hot, so I'm using the fan. The cold air coming from the fan touches my body surface. It will absorb the heat and it will rise. The hot air rises in the atmosphere. For example, the water present in our lake, river, ocean, etc. by sun's solar radiation, it will evaporate, right? It will evaporate and it will form clouds, right? This is also convection. Convection. Have you anytime used immersion coil to heat water? Immersion coil. Here what will happen? You will check the water if it is hot or not. By checking here, you feel like the water is hot. But after some time, you feel cold water here. You will get cold water at the bottom because upon heating, the hot water rises and it is stored at the top. The cold water is still present at the bottom. Convection, convection. And you have seen the solar water heater, right? Solar water heater. In the solar water heater, there are so many tubes. Is there any pump? Is there any pump present in the normal solar water heater? No. Generally, the solar water heater will not draw any electricity. It directly works with the help of getting solar heat radiation, right? You have placed the overhead tank above the level of solar water heater, so the water can easily flow into the solar water heater, right? Once the water flows through these pipes, what will happen? The cold water goes down, the hot warm water moves up. Hot water, the hot water is stored at the top. Hot water stored at the top, cold water present at the bottom. Hot water at the top, cold water at the bottom, like this. Generally, if you observe, the inlet will be at the bottom, outlet will be at the top. Outlet in the solar water heater. Why? Convection. Hotter molecule rises. For example, in our, have you gone swimming in any of the lakes overflowing or a river where the water is flowing? You might have felt the cold water at the bottom, comparatively warm water at the top. You might have felt the cold water flowing at the bottom. Reason, the density of cold water is more, the density of hot water is less, so hot water will be at the top. You will study a topic, very important topic in geography, ocean currents. Ocean currents. Geography is the subject, or geography. Geography class are complete or not? Not yet. Okay, see here. Here, warm water from the equator moves to the polar region. At the top surface, literally, the water will flow. Thousands of kilometer wide, hundreds of kilometer deep, water will flow. It will literally flow from equator to the pole. This current, this current of water is called as warm current. Then from the polar region, cold water travels to the equator region. Cold current, warm current, cold current. Very important topic. There are so many varieties, types of current named after many places, etc. You need to study in geography, right? Ocean currents, ocean currents. Ocean currents are due to convection. Convection means when gas or liquid is heated, it will rise, it will move up because the density is less. This is convection. Convection. Then radiation. Radiation requires no medium. It requires no medium. All hot objects radiate heat, radiate heat in all directions, in all directions. All hot objects radiate heat in all directions, in all the directions. For example, during your school days, after a busy 2-3 hours of sports period, the last class was conducted by a maths teacher, let's say. You are sitting in the class, you are fully tired, sweaty. You can feel the heat coming from your body. even the heat coming from your friend's body, right? The heat moving out. When a hot pot of water or food, the cooker, let's say, it will radiate heat in all the directions, right? That is radiation. Hotter objects radiate heat in all the direction. For example, let's see. You have created fire. Few people are sitting around this campfire. Okay. One person is trying to cook some food with the help of a metal rod skewer. He is using his hand directly. Okay. Then a person standing here, he placed his hands above the fire. See, you might have experienced this candle flame. If you place your hand here, what will happen? After some time, you will feel the heat, right? Above the candle. Why you feel the heat? You are many centimeters above the flame. Because for combustion to happen, oxygen is required. Oxygen is required. Oxygen is utilized, then carbon dioxide is released. This hot carbon dioxide will cause your hand to be heated. This is called as convection. Convection. The hotter air rising upward. This is convection. Okay. After some time, the metal rod present here will be heated, right? The person holding it will feel the heat, right? This is from hotter end to the colder end. The heat is traveling. This is through the metal iron rod. This is conduction. Conduction. A person sitting simply few feet away from the campfire, still he feels the warmth, right? Even though he is sitting few meters away from the campfire, he feels the warmth because heat is radiated in all the directions. Heat is radiated in all the directions. This is due to radiation. This is due to radiation. He feels the heat. Radiation. Okay. Temperature scales. Let us discuss three important temperature scales. Freezing point of water. Freezing point of water. Freezing point of water means at a temperature where water in liquid state is converted into solid state. Ice cube, the temperature. Freezing point of water. This is Celsius scale. This is SI net Kelvin scale. This is Fahrenheit scale. Fahrenheit scale. Fahrenheit scale. Freezing point of water in Celsius scale is 0 degree Celsius. In Kelvin scale is 273 Kelvin. In Fahrenheit scale it is 32 degree Fahrenheit. 32 degree Fahrenheit. They can ask freezing point of water or melting point of ice cube. Melting point of ice cube. Both the melting point of ice cube and freezing point of water both are same. Even the water freezes at 0 degrees Celsius. Ice cube melts at 0 degrees Celsius. Same temperature, phase change happens at the same temperature. Both freezing and melting point. Then boiling point of water. Boiling point of water. Boiling point of water. Or evaporation point of water. Boiling point or evaporation point. Evaporation point. Evaporation point means the temperature at which liquid water is converted into vapor form. Liquid water to vapor form. Evaporation point. Boiling point of water value 100 degrees Celsius. Boiling point 100 degrees Celsius. In Kelvin scale it is 373 Kelvin. In Fahrenheit scale it is 212 degree Fahrenheit. 212 degree Fahrenheit. Boiling point of water. Then very much important, average human body temperature. Average human body temperature. Average human body temperature. Average human body temperature is how much? 37 degrees Celsius. Good. 37 degrees Celsius. In Kelvin scale it is 310 Kelvin. 310 Kelvin. In Fahrenheit scale it is. You might have heard in many movies. Generally, the hero or heroine will be having fever. The fever which they address as, oh, she is having 100-degree fever, 102-degree fever, 103-degree fever. Have you heard? Fever in 100, 101, 2, 3 degrees. Actually, that is Fahrenheit scale, not the Celsius scale. Celsius scale means 100-degree boiling point of water. Will our body be at that temperature? No, not at all possible. Fahrenheit scale, they will be telling average human body temperature in Fahrenheit scale is 98.6 degree Fahrenheit. 98.6 degree Fahrenheit in Fahrenheit scale. Fahrenheit scale. Okay. Then one more important thing. At what temperature values? At what temperature values degree Celsius value is equal to degree Fahrenheit value means? See, 0 to 100, 32 to 212, both are moving up. At some point, they will meet either upward or downward. The point where they meet is minus 40. Minus 40 degrees Celsius is equals to minus 40 degree Fahrenheit. Minus 40 degrees Celsius is equals to minus 40 degree Fahrenheit. Then, very much important, absolute zero. Absolute zero. Absolute zero. Absolute zero means if we heat any object, it will expand, right? If we cool, it will compress. Upon heating, it will expand. Upon cooling, it will compress. Expansion, compression. Absolute zero means at a temperature where there is no molecular movement. Molecular movement is freezed. It will not expand, it will not compress. The temperature is called as absolute zero. No molecular movement. 0 Kelvin, 0 Kelvin, minus 273 degrees Celsius, minus 460 degree Fahrenheit. This is absolute zero. This is absolute zero. Absolute zero. Then one more important thing. Triple point. Triple means three, right? Triple point means a temperature where the object is in solid, liquid, as well as gaseous form. At that temperature, the object can or should be in all these three phases: solid, liquid, gas. At what temperature it is possible for water in your freezer, in your refrigerator's freezer portion? At 0 degrees Celsius, water can be present in liquid form. At 0 degrees Celsius, water can be present in solid form, ice cube. When you open the freezer, the vapor comes out, right? The vapor, right? So 0 degrees Celsius, this temperature is called as triple point of water. Triple point, triple point of triple point of water. This temperature, 0 degree Celsius, triple point. One second. Okay. We have Celsius scale, Kelvin scale, and Fahrenheit scale, right? If we need to convert degree Celsius to Kelvin, we should add 273. For example, 0 degrees Celsius, 0 plus 273 is equals to 273 Kelvin. Degree Celsius to Kelvin. If you want to convert from Kelvin to degree Celsius, minus 273 we can do, minus 273. For example, 373 Kelvin minus 273, that is equals to 100 degrees Celsius. 373 Kelvin means boiling point of water, 100 degrees Celsius. We can use this formula. And for degree Celsius to Fahrenheit conversion, degree Celsius is equals to 5 by 9 into F minus 32. Formula is there. Degree Celsius to Fahrenheit conversion. Fahrenheit conversion. Say in Celsius scale, in the Celsius scale, 0 degree to 100 degree, 100 equal parts 1, 2, 3, 4, 5. In the Kelvin scale, in the Kelvin scale, 273 Kelvin to 373 Kelvin. This is freezing point of water, this is boiling point of water. Freezing point of water, boiling point of water. Here, 100 equal parts. But in Fahrenheit scale, 32 degree Fahrenheit to 212 degree Fahrenheit, 212 degree Fahrenheit. How many parts? 32, 212, 180 equal parts. So, accuracy is more in Fahrenheit scale. That's why human body temperature is measured in Fahrenheit scale. Fahrenheit scale. And in India, we generally use Celsius scale, but the SI unit of temperature is Kelvin. SI unit of temperature is Kelvin. Kelvin. Specific heat. Symbol C, specific heat. Specific heat means a unit quantity of material is there. For example, 1 gram of material is there. Right now, its temperature is 10 degrees Celsius. Its temperature is 10 degrees Celsius. To raise the temperature by 1 degree Celsius, to raise temperature by 1 degree Celsius, the amount of heat required, the amount of heat required, the amount of heat required is specific heat. Is called as specific heat. Amount of heat required to raise the temperature by 1 degree Celsius. If this water's temperature is 20 degrees Celsius, the amount of heat required to raise the temperature by 1 degree, that means 21 degree, that is specific heat. The heat required is called as specific heat. Specific heat capacity of copper, iron, water, gold, which is more, they will ask, which substance is having more specific heat capacity. That means to increase temperature by 1 degree Celsius, which of these substances will use more heat? Which will use more heat to raise 1 degree Celsius? Which will use more heat? Metals are good conductors, right? Metals are good conductors. Just observe, in your stove, one side you have put metal pan, other side you have put water to boil. Which will take less time to be heated? Metal, right? If 1 kg of metal, 1 kg of water also, which will heat earlier? The metal, right? Metal heats up fast, it cools down fast. Metal is a good conductor. Good conductor means which should heat up fast and also cools down faster. Here, which heats up slower? Water heats up slower. The specific heat capacity of water is more, very much important. The specific heat capacity of water is more than general substances which we use in our regular day-to-day life. Specific heat capacity of water is more. Specific heat. Then we have latent heat. Latent heat. Heat present in secret form, secret, hidden heat, we can say. Latent heat means ice cube is there at 0 degrees Celsius. Ice cube is there at 0 degrees Celsius. You are heating this, you are applying some heat. Then at a 0 degrees Celsius only, at a 0 degrees Celsius only, it at 0 degrees Celsius only it starts to melt, right? Ice starts to melt. At the same temperature, the phase change happens. At same temperature, the phase from solid to liquid is happening. When you start to boil water, when you start to boil water, it will reach 100 degrees Celsius and it will start to boil. At 100 degrees Celsius, it will start to evaporate. The temperature will be the same, 100 degrees Celsius only. But the hidden latent heat will be in this steam. The hidden latent heat will be in this water. This is latent heat, secret heat. At the same temperature, the phase change is happening. Just imagine you are boiling water. 100 degrees Celsius temperature boiled water falls on your hand. 100 degrees Celsius boiling water droplet falls on your hand, and 100 degrees Celsius temperature steam touches your hand, which by which you feel more burning, water or steam, right? Because of latent heat. When compared to boiling water at 100 degrees Celsius, when compared to boiling water and steam at 100 degrees Celsius, it will be having more heat in the form of latent heat. This latent heat can be used to steam food, idli, momos, etc. by the help of steam, latent heat. Okay. Then why water placed inside a mud pot is cooler than the water placed outside? Inside the mud pot, the water is cold, right? Why? How? Because there are minute pores, small pores present in this mud pot, which we cannot see. Small pores. Once you pour water into the mud pot, the color of the mud pot changes. It feels wetty, right? The dry mud pot looks wet, but it is not leaking. It looks wet. What happens? The water comes out from these pores. Water comes out from these pores and it will evaporate. Water will evaporate. The water coming out from the pores and it is evaporating, right? It is evaporating by absorbing the heat from the water inside. It is absorbing the heat from the water inside. That's why the heat is absorbed, the water is evaporated, hence the temperature inside will go down. It is reduced. In recent days, many artisans started to paint these pots. If you paint these pots with color paint, what will happen? The pores will be closed. Upon painting, the pores will be closed. No use. The main function agenda of this mud pot will be lost here, right? So pores should be there. Pores should be there. Then let's discuss about Newton's laws of motion. Newton's laws of motion. How many laws of motions are there? Three. First, second, third law, right? Generally, we know the third law. For every action, there is a equal and opposite reaction, right? See, Newton's first law. Newton's first law is called as law of inertia. Law of inertia. Inertia. Newton's first law. Here, see, Newton's first law says if the object, a person, is at a stationary position or in uniform motion, either in stationary position or in uniform motion, until and unless the external force acts on that body, until and unless the external force acts on that body, it will continue in its state of rest or uniform motion. It will continue in the state of rest or in the state of uniform motion. For example, you are traveling in a car. You are traveling in a car at 60 kilometer per hour speed. 60 kilometer per hour speed. Suddenly you brake. Suddenly you apply the brake. Your upper body will tends to move forward, right? That is the reason you use seat belts. You tends to move forward. This is called as inertia of motion. The inertia which you have due to motion. With the speed of the car, your body is also moving. You are sitting inside the car is moving at 60 kilometer per hour. Your body is also moving at 60 kilometer per hour. When you apply the brake, the lower body, which is in contact with the car, slows down. But the upper body, it moves forward. It moves forward because it tries to continue in the state of motion. Earlier, it had motion, right? It tries to continue in the state of motion called as inertia of motion. You have a bottle of water above which we have placed a cardboard sheet. Above the cardboard sheet, we have placed a coin. If you move the coins, the cardboard sheet suddenly, what will happen? The water bottle is here. Then we have paper. If I move this paper, suddenly what will happen? The water bottle will stay here itself, right? Likewise, if I move this cardboard sheet, the coin will fall here itself. This is inertia of rest. The water bottle here or the coin there is at rest. Even though the surface beneath it is getting motion, this object continues in the state of rest. This is called as inertia of rest. Inertia of rest. In one examination, they have asked a question. The floor mat you have, right? You are cleaning the mat by tapping it hard. The dust particles are falling downwards. This is inertia of rest or motion they have asked. You are cleaning the mat by tapping it fast. The dust particles are falling there itself. This is inertia of the mat is having the dust particles, heavier dust particles. The mat is getting motion, but the dust particles continues in its state of rest. The dust particles present here continues in the state of rest. That's why it falls there itself, inertia of rest. You are traveling in a bus. You are traveling in a bus. Suddenly the bus brakes. You tends to move forward. That is due to inertia of motion. Inertia of motion. You have the same motion speed which the bus is moving with. When the bus suddenly brakes, the lower part of your body, the feet in contact with the bus, tries to slow down, but the upper body moves forward. Inertia of motion. Inertia of motion. Then there is a special case they have asked in the examination. The bus is moving in a straight line. The bus moving forward in a uniform direction. You are standing here near the footboard. Okay. When the bus takes sudden right turn, sudden right, you tends to move outward, you tends to fall away, right? This is due to inertia. Yes, inertia of, this is due to inertia of direction. Inertia of direction. See, when the car is moving in the circular path, the car, if it is speeding, when the car moving the circular path, if the car is speeding, the car might fall off. This is a centrifugal force, circular motion, force acting away from the center. That is centrifugal force. Here, the bus moving in a straight line, in a uniform direction. When there is a sudden right turn, the person standing in the footboard falls off. This is inertia of direction. These three things important. Inertia of motion. Initially, the person object should be in motion. Inertia of rest. Initially, the object should be in rest condition. Inertia of direction. This one. You are sitting in a bus. You feel the seat is dirty. You are sitting little far from the seat. When bus starts suddenly, you just move backward, right? That is inertia of rest or motion. You are sitting in the stationary bus. The bus starts suddenly. You tends to move backward. That is inertia of rest because you are at rest, right? You are at rest. The bus starts to move forward, backward. Inertia of rest. Important thing. Inertia is dependent or directly proportional to mass is dependent on mass. For example, if a small car moving at a speed of 60 kilometer, a big truck moving at a speed of 60 kilometer, a small car and big truck moving at a speed of 60 kilometers. If both these two vehicles hits a person, object, anything, which will cause more damage? The bigger one, the heavier one, right? And the braking force required is more in the bigger vehicle because inertia is more when mass is more. Inertia will be more when mass is more. Newton's first law. Then we have Newton's second law. Newton's second law. Simply it says force is equals to mass into acceleration. Force is equals to mass into acceleration. Acceleration means acceleration. Acceleration is equals to velocity by time. Rate of change of velocity. Rate of change of velocity. Acceleration. Acceleration. In your vehicle, you have accelerator, right? You are moving in a single direction. You accelerate. Your speed varies with respect to time, right? That is rate of change of velocity. Rate of change of velocity, that is acceleration. SI unit of acceleration is meter per second square. Acceleration is measured in meter per second square. SI unit of velocity is meter per second meter per second square. Acceleration. Here Newton's second law. An object is moving in one direction, right? You are applying force in the same direction. You are pushing a car, right? If you apply more force, it will move with more speed, more velocity, right? The force is directly proportional to the acceleration. Acceleration means rate of change of velocity, and the force and acceleration are in same direction. Force and acceleration both are in the same direction. Then you are applying the same force which you have applied to this car to a bike, means which will move fast, the car or the bike? Bike will move fast because mass is less, right? Mass and acceleration are inversely proportional. If the mass is more, acceleration is less. If the mass is less, acceleration is more. Force directly proportional to acceleration, acceleration inversely proportional to mass. Combining these two, we get the equation called force is equals to mass into acceleration. Force is equals to mass into acceleration. SI unit of force is Newton. SI unit of force, Newton. The application based question which they have asked in an examination, a football player, he is kicking two balls, a smaller ball with lesser mass, bigger ball with more mass, small ball with less mass, big ball with more mass, with the same force. With the same force, he is kicking these two balls. Which ball will travel more distance? The smaller one. The smaller will travel more distance when compared to the bigger one. Acceleration inversely proportional to the mass, right? Inversely proportional. Mass is more. That's why it traveled lesser, shorter distance. This is Newton's second law. Second law. Then the most famous law, Newton's third law. For every action, there is There is equal and opposite, reaction, equal and opposite reaction, right? For example, there's a rocket. If you ignite, then the gases will burn and move downward. The rocket will move upward. If you get hit, if you hit someone, you and him both will feel the pain. That is Newton's third law, not you showing the cheek again, right? Newton's third law. They have asked in an examination, upon kicking a stone, a person is hurt. That is due to. Upon kicking a stone, a person is hurt. If you kick the stone slowly, you feel less hurt. If you kick the stone fiercely, you feel more hit, more hurt, right? That is third law. For every action, there is an equal and opposite reaction. If you bounce a ball, pitch a ball, it will bounce back. Newton's third law, right? In an examination, they have asked a question. There is a rifle. There is a rifle. Okay. From the rifle, you are firing a bullet. From the rifle, you are firing a bullet. Okay. When compared to the speed of the bullet, when compared to the speed of the bullet moving forward, what is the speed of the rifle moving backward? There will be retaliation, reaction force, right? When compared to speed of the bullet, the speed of the rifle will it be same as the speed of the bullet, less than the speed of the bullet, more than the speed of the bullet? Why? If we stick on to the equation or the definition, it says for every action there is an equal and opposite reaction. But equal speed will not be there. It cannot be there. If the rifle comes back in the same speed as the bullet goes forward, the rifle will not be in our hand itself, right? Retaliation speed will be less because mass matters here. Mass of the bullet is very less. Mass of the rifle will be more heavier, right? That's why it moves with a lesser speed backward. It moves back with a lesser speed, right? Newton's third law. Newton's third law. A person is sitting on a chair. You are sitting on a chair. If I suddenly move the chair backward, you will fall there itself. That is Newton's law of inertia. Inertia due to rest. Newton's first law, inertia of rest, right? Okay. Take a break for 5 minutes. We'll continue later. Sir. ಫಸ್ಟ್ ಒನ್ ಆನ್ ಆಗಿತ್ತಲ್ಲ. ನೀವು ಆಫ್ ಮಾಡಿದ್ರಾ? ಸ್ವಲ್ಪ ಲೂಸ್ ಕನೆಕ್ಟ್ ಆಗಿದೆ. ಓಕೆ.